Good evening, Year 10. Welcome. Here today, I have an assortment of spheres. This thing here, I don't know quite what it's meant to do. They're like somewhat bouncy, not really any weight in them. Is a cat meant to play with them? I got things like this hanging around. Another sphere. Gotta be really careful. The baby thinks it looks delicious. Got this, handballs. You guys use these bouncy balls. Someone would have got hurt in my day using these things for handball. But you guys, you're so much nicer than we were. So, these things work interestingly as handballs. It's a sphere. I've got this thing, somewhat like a sphere. It's got some markings in it which detract slightly from it. I got this, not really a soccer ball. It seems to have aspirations to be one, but it's not quite there. Soccer balls aren't technically spheres, I believe. You can have a good Google about that if you want. You may know spheres by other names. That's up to you. But today, we are talking about spheres. And we are, in particular, going to be doing the surface area and volume of spheres. So let's do that. I have decided, it's not meters. I've decided that the radius of our handball here is probably about 3.5 centimetres. I don't have the heart to chop it in half to check that. I hope you'll be okay with that. For finding the surface area and volume of spheres, there are two formulas, and if you can use them, you can find the surface area and volume of the sphere. Despite it being extension content, it's not actually too horrible, this content. So let's do it. All right. So a question here could be, find the surface area and volume of the above handball. It provides challenges for us nerds to make a three-dimensional object like this look two-dimensional, and so we try to put this little line here to try and give you a little bit of a shine like you're seeing three dimensions, and that's pretty well the best we've got, unless you use shading, which I think the textbook's taken too. Anyway, so surface area, here's your formula. Surface area is 4 pi r squared. The only thing you need is the radius. So in this case, it's 4 times pi times the radius is 3.5, so we square it. So we put that in our calculator. 4 times pi times 3.5 squared. Press equals, and there we go. We've found the surface area of this. If I was to paint this handball, be more likely to paint some of these other things here. I don't know how these ended up in our house. I think they randomly come out of machines in places that we used to visit before lockdown. You'd want to paint over them. So, interesting question. How much surface do I have to paint? Well, that formula will let you work it out. So in this case, you put that in your calculator. We are rounding here to 153.94 centimetres squared. Right, so that's the surface area of this object. Volume is the second formula you need to learn today. So volume is simply 4 over 3 pi r cubed. Again, the only thing you need to put in this formula is the radius. So it's 4 over 3 times pi times the radius, which is 3.5 to the power of 3. So we're going to put that in our calculator. We're going to go 4 over 3 times pi, use the pi button as always, times 3.5 to the power of 3. There it is, equals, and we've got the volume, the amount of goop that had to be put in this handball to make it the beautiful handball that we enjoy today. So 179.59, and its volume, so we're in 3 dimensions, so I'm going to be calling that centimetres cubed. All right, how does that look, everyone? Looking all right? That's fundamentally the lesson for today. So surface area of a sphere is that formula, volume is that formula. You need to be able to use them. Now, obviously I'm thinking we need to do something much harder than that. So I am going to do a strange and interesting, challenging question that I thought of recently. We'll go through that and that'll be it for today on spheres. So, the challenge question that I'm going to do is find the surface area of a sphere that has a volume of 4.8 meters cubed. So that's an interesting conundrum, isn't it? How do I get from one to the other? The important thing to note about the sphere formula is it only takes in one dimension, and that dimension is the radius. So the key to most of these tricky questions is, well, what's the radius? If you can find the radius, then you might be a chance to then find the surface area, which is what we are asked to find. So let's give that a go. Right, so first off we're told the volume is this. So you need to remember the volume formula for a sphere. The volume is 4/3 pi r cubed. And we're given the volume, it's 4.8. We need to be able to solve that. We need to find an expression for r before we can progress things here. So let's do that. The opposite of dividing by 3 is multiplying by 3. If I multiply both sides by 3, what's that times 3? 14.4, I believe. We believe all sorts of things. Hopefully that stands up. 4 pi r cubed. The opposite of multiplying by 4 pi will be dividing by 4 pi. So I could do that. That will give me r cubed, I'm swapping the sides here as well, is 14.4 divided by 4 pi. Maybe we can simplify that 14.4 divided by 4. We might be able to do that. Yeah, 14.4 divided by 4 will just give you 3.6. So I might simplify that slightly. All right, so I just did 14.4 divided by 4 to clean that up. Now here's interesting. How do I get an expression just for r? The opposite of squaring is a square root. But what's the opposite of cubing? If you remember that, it's the cube root. So that gives us the radius is equal to the cube root of 3.6 over pi. Now I could put that in a calculator and find an approximate value for that, but the further we get in mathematics, the more we want to work in exact values where possible. So let's leave radius as that expression, the cube root of 3.6 divided by pi, as weird as it looks. The original question asked the surface area, so let's go ahead and do that. So the surface area formula for a sphere, as we did before, is 4 pi r squared. So let's do that. That's 4 times pi times the radius. That's the radius. Cube root of 3.6 over pi. And we're going to square it because it's the radius squared. So your biggest challenge there is going to be getting that in a calculator because that's quite a messy looking expression. 4 times pi times, open the bracket. Need to open a bracket there. Then I need cube root. I can't tell you where exactly it is on your calculator, but it will be there. Cube root of a fraction. That fraction being 3.6 on the top and pi on the bottom, close brackets, to the power of 2, looks great in a calculator, equals, and it's giving me a surface area then, so I'm just going to check 4 times pi times cube root of 3.6 over pi squared. Yeah, it looks all good. Is approximately, because we are going to be rounding now, 13.76. Our units are meters squared. Area is two-dimensional, therefore the units are squared. Right, so that's lots of fun. You'll also find the text has an example of finding the volume of an object which has a cone with half a sphere on the top, sort of like an ice cream. That's an interesting example too, which is quite different to this one, if you'd like another example. Alas, that's spheres. You need to be able to work out surface area, you need to be able to work out volume. Have fun.